Hi everyone, today I am demonstrating how to use a simple acids and bases experiment to enhance student learning in a science classroom. This activity supports understanding of chemical reactions, properties of matter, and scientific inquiry skills. This experiment uses inexpensive, accessible materials, so it will be easy to replicate in the classroom. Vinegar and lemon juice serves as acids, and baking soda represents a base. Dish soap and water provide comparison substances. This makes the activity practical for most classroom settings. We will begin with testing baking soda and vinegar. This reaction clearly demonstrates evidence of a chemical change through visible gas production. Before conducting the experiment, I would begin with a class discussion. I would ask the students, what do you already know about acids? Where have you seen them in real life? And what about bases? I would then explain that acids and bases have different chemical properties, and when they combine, they often undergo a neutralization reaction. When vinegar, which contains acetic acid, reacts with baking soda, which is a base called sodium bicarbonate, carbon dioxide gas is produced. This gas production is the key observable evidence students will focus on. So for this experiment, we will be using baking soda, vinegar, a clear container, and measuring tools. Clear containers are important so students can observe the reaction clearly, as I previously stated. So step 1, I'm going to place approximately 1 tablespoon of baking soda into a clear cup. In a classroom setting, I would ask the students to observe the baking soda first and describe its physical properties. They can use describable terms such as it is a white powder, dry, and odorless. Step 2, I'm going to measure approximately 1/4 cup of vinegar, and then I would ask the students to predict what will happen when the vinegar is added. I am now going to slowly pour the vinegar into the baking soda. So as we observe, bubbling begins immediately, and the bubbling is carbon dioxide gas escaping from the reaction. I would guide students to identify this as evidence of a chemical change because a new substance, carbon dioxide gas, has formed. What occurred was a neutralization reaction, and the acid and the base combined, rearranging atoms and producing carbon dioxide gas, water, and sodium acetate. In the classroom, I would emphasize this is not simply mixing, but a new substance being formed, which distinguishes chemical change from physical change. To deepen understanding, I would next introduce a comparison test. So I am now going to add 1 tablespoon of baking soda into this cup. Step 2, instead of vinegar, I'm going to add plain water. As we observe, there is no bubbling. This helps the students understand that not all liquids react with baking soda. This strengthens their ability to classify substances based on evidence. For more comparison testing, we will now use lemon combined with baking soda to see the results. So I will now add 1 tablespoon of baking soda to another clear jar. Again, we can ask the students to predict what will happen before adding the lemon juice. I will now prep some lemon juice so that I can pour it directly into our third experiment here. Lemon juice is also an acid, so this will allow the students to compare a different acidic substance and analyze the reaction strength. So here we go. So as we can see, it is bubbling, but not as much as it did when combined with the vinegar reaction. So at this point, you could ask the students to compare which acid appears to react more vigorously and why. I hope you all enjoyed this experiment demonstration on acids and bases and have fun experimenting with your students. Thank you. To make the lesson more engaging and to visually capture the gas produced, there's an opportunity to use a balloon to show the collecting of gas. You would do this by pouring vinegar into a plastic bottle, then placing baking soda inside of a balloon using a funnel, and then carefully stretching the balloon opening over the mouth of the bottle without allowing the baking soda to yet fall in. And then when you are ready, lift the balloon to let the baking soda fall into the vinegar, and the balloon will lift and inflate. So that reaction occurs, carbon dioxide gas fills the balloon, and this would provide strong visual evidence of gas production and increase student engagement. So this activity supports inquiry-based learning because students begin with predictions, observe evidence, compare results, and explain outcomes. It addresses science standards related to chemical reactions, properties of matter, and scientific investigation practices. For younger grades, the focus remains on observation and cause and effect relationships, while for older grades, this can extend into chemical equations and pH scale discussions. So in summary, this acids and bases experiment is cost-effective, safe, visually engaging, and adaptable across grade levels. It transforms abstract chemical concepts into observable phenomena that students can analyze and explain. Thank you.